Integrated circuits, ICs, are commonly the main parts of the electronic circuits. They each have unique specific functions. If you need to boost your signal, you can use a buffer. If you need to trigger some events by the status of a signal, you can use logic gates. If you need to compare some signals, you can use a single comparator. There are many types of ICs designed and produced by different manufacturers. But a few series have a common usage, like 7400, 4000 and LM series. They are usually produced in small packages, like DIP, SOIC, QFP, QFN. DIP package is very popular. It's compatible with breadboards. There are some difficulties with learning, testing and using ICs. Small packages are good for mass production because of covering small areas. But it is not possible to set them on a breadboard. After you draw your circuit and simulate it, you want to see how the real circuit behaves with real components. You need to test your circuit on a breadboard, but if it's in an SMD form, it has to be converted to DIP. That's the first issue. ICs are designed and produced by priority of bulk production, for small volume and low cost. Inside the chip, the shortest line is preferred for wiring, from the core to the closest pin. This choice is about the performance and cost by the producer's side. But in application, on a breadboard or even on a printed circuit board, it can be hard to use the pins effectively. Some of the relative inputs and outputs are placed on irrelevant corners of the package. For the user, the connections are far away from each other. These facts can turn into annoying difficulties, especially with combinational circuits based on multiple ICs working together. While testing a multi-chip circuit, error detection can be very troublesome. It becomes harder to find which cable, from which IC pin is not attached, which cable is shorted, which part of an IC is burned out, or malfunctioned. These steps are taking the most of your time, instead of development process. That's the second issue. I offer a project. ICE. Integrated Circuit Expanders. For saving time of all electronics students, makers, hobbyists. NEs for anyone who just wants to learn electronics, without drowning in ugly data sheets, and messy cable connections. NICE mainly carries out these actions. Converts package to DIP for prototyping. Arrange relative IOs and power planes for cabling. Clearly indicates the pin connections for testing. Conversion. You can solder your package at the bottom of the expander, and add some headers to the both sides. So your new IC is suitable for almost every breadboard. If it's already DIP, it needs a bit longer headers for the greater height. Arrangement. By these expanders, every package will have a new pinout. This new pinout is taken into account from a few aspects. All the inputs are placed on the left side. All of the outputs are on the right side. Voltage and ground connections are on the bottom left. Extra pins like chip select, enable, disable, clock, shift, set, clear, are placed on another functional area. And any pin that is not an input itself, but related to an input, is located on the left. Same rule is valid for output-related pins. Different function blocks are placed side to side. Instructions and tooltips. For the package is soldered on the bottom, there will be a significant area at the top for silk screen, which can be used for symbol-based tooltips. The IC is represented by a general logical symbol as possible as. Inverted I/O and pins are represented by a small empty circle at the end of the pin. Package-related extra features are represented by a dotted rectangular area, like common clock, all enable, or chip reset. The complete project will be presented as open source electronics. Any user will be free to use, change, share, or even sell the boards. That's the main goal of this project. For the developing process, for 1 or 2 years of mine, according to the request, I decided to keep going with the idea of unit cost. For developing completely one unique board, from start to finish. Every new contribution at unit cost, as time for engineering, will launch a work for a new board entirely. For the project planning, the needs and usage ratios will be researched of ICs for common series like logic gates, comparators, operation amplifiers, voltage and current regulators, switching ICs, audio amplifiers, LED drivers, timers, etc. From the very common ones first, to the rare, a large scale of ICs will be scanned. You can send your request if there is one, in this period. All your requests will be considered as the priority of production during the project for each of the new boards. Data sheets of different manufacturers will be studied for main function of the chips. Then the package forms will be collected. The pinout variations will be decided for best usage. Package will be at the bottom of the board. Traces are drawn wide as possible for power and heat dissipation. Silk screen will be illustrated at the top of the board. All the information about the package will be placed as symbols or characters on the board. When the board gets ready, it will be converted to a Gerber file. A Gerber file has all the information about a board for production. The schematics and new pin sequences will be generated as image. All this files, an editable circuit file for Proteus, a Gerber file, a pinout image, a text file for extra notes, will be uploaded to the project's website. Anyone at any time will be able to use all the site content. As a register kit, as a flip-flop kit, as a multiplexer kit. It will be a source of integrated circuits and their own expanders. Download as many as you want, all the kinds of boards you need. Send them to your favorite PCB manufacturer. Solder your ICs on, and fun with using them. Less time for searching, cabling, and error detection. More time for developing, proper thinking, and creativity.